Hi everyone. So in the tutorial I am going to talk about the rest of the control signal that we didn't discuss in our previous lectures, like ALE, S0, S1, and among these three control signal, S0 and S1 is a status signal and ALE is a control signal. So now let's first discuss the ALE, which is a control signal. What is ALE? ALE. The full form of ALE is address latch enable. Address latch enable. So as we know that 8085 microprocessor has a 16 line, so 16 line are allocated for address bus. So address bus has how many line? Address bus has 16 lines. And as we also know that 8085 microprocessor data bus or data bus is 8 bit, that means 8 lines are there. This is the basic features of 8085 microprocessor. So address line is 16 bit and data line is 18 bit. So if we wants to, in the chip we have seen that there are 16 address line available in that chip, and if we wants to send some data from microprocessor to the memory or the vice versa, then how does we use those address line as a data line? How does we manage those address line, those 16 address line into the data line? So let's write here the address line is that we have seen A0 to A15. So now divide this address line into two part. One is A0 to A7, which is a lower order address line, and this is and rest of the is 8 to A15. This is called higher order address lines. Lower order address line and the higher order address line that you can see over here. So now this lower order address line is, this lower order address lines are time multiplexed with the bidirectional data bus. This lower order address lines are time multiplex to get a data line. What we will do, this lower order address lines are time multiplex with bidirectional data line. So when we will multiplex those line, this lower order address lines to the bidirectional data line, time multiplex bidirectional data line, at that case we will write this A0 to A7. Instead of A0 to A7, we will write it as AD0 to AD7. So these are the 8-bit line. So this line is called address, this line is called multiplexed address data lines. So this lower order line is called multiplex address data line. What does it mean? That means that this line, this 8 line, sometime will work as a data line and sometime it will work as a address line that you can see over here. But this higher order address line always remain as a address line, but this lower order address line sometime it will work as a data line, sometime it will work as a lower order address line. That's why it is called multiplex address data line. Then how does microprocessor know that it is a address line or it is a data line? So at that case it's required to generate, it's required a ALE signal. So by enabling the ALE signal, by making it 1, by enabling the ALE signal, enable, or by make it high, or you may say 1. So by enabling the ALE signal, make it high or 1, at that moment when the ALE signal will be 1, all A0 to A15 will work as a address bus. But when it will disable, but when this signal will disable, that means ALE equals to 0, that means AD0 to AD7 only will work as a data line, will only work as a data line, that you can see over here. So when, then a simple way, in a summarized way, if I would say that ALE equals to 1, that means A0 to A15 is the address line, ALE equals to 0, that means AD0 to AD7 is a data line. So that is a conclusion. That is the conclusion of this line ALE. As we have seen just earlier, if microprocessor wants to convert the data bus to its lower order address bus or lower order address bus to the data bus, how does it convert? It convert by simply generating a control signal, which is ALE. So my next question is, if microprocessor wants to achieve the conversion process, then how does the microprocessor achieve the conversion process? Microprocessor achieve the conversion process by time multiplexing between the data bus with the lower order address bus, that you can see over here. So I have depicted this picture here, and in that picture it is showing that how does the microprocessor achieve the time multiplexing process between the data bus and the address bus, and this circuit really helps to convert, to achieve that conversion, this circuit. So as you can see, this is a data bus, 8-bit data line is here. This is a lower order address bus, 8 address line is here, and this is a higher order address bus, which is the 8 address line is also here. So the signal which we were looking for, that was the ALE, address latch enable. So as you can see, if we will multiplex this lower order address line with this data line, then the signal we will called as multiplex address data line, that you can see AD0, AD1, AD2. So I have symbolized in that way. So now let's drive into this circuit. So as you can see here, so this circuit is comprised of 8 flip-flop, 8D flip-flop. As you can see, 1, 2, 3, in that way 8D flip-flop, and all the D flip-flop is connected with each address line. A0 connected with a D flip-flop, A1 also connected with a D flip-flop. So if you will notice, then you will see that this D flip-flop can be enabled or disabled by applying a high or low signal into the circuit, and this signal is an enable signal. This pin is enable or disable pin, enable or disable pin. So by that pin we can enable it or disable it, and this pin is actually the ALE pin to the microprocessor, address latch enable. This pin is connected with the ALE pin to the microprocessor, address latch enable. So if the ALE is 1, that means the circuit will be enabled, the D flip-flop will be enabled, and then the circuit will be activated. And when the ALE will be 0, this D flip-flop will be deactivated, the circuit will not work at that time. So let's see the process. So suppose if ALE equals to 1, that means we have provided a high value to the ALE signal. If ALE is 1, that means it will make all the D flip-flop active, the whole circuit will be active here. So as you can see, if we want to, let's take a address which is a 4020. So here is the address, and 40 is a higher order address, higher byte of the address, and 20 is a lower byte of the address. So lower byte of the address, we will send this lower byte of the address by the lower order address line. So now 20 is, I have put 20 here, so we want to send this lower order address to the memory microprocessor, from microprocessor to the memory through this circuit, through this time multiplex circuit. And we have provided AL equals to 1, that means the circuit is activated. So as you can see, all our flip-flop is a D flip-flop. So from the property of D flip-flop, we know that we know that if this is a D flip-flop, and if I will provide a input here, we will get a output here. So this input will be equals to the output. That means when the circuit will be activated, when we will, at that moment, when we will provide a lower byte of the address, when we will provide a lower byte of the address to the circuit, this byte of the address will be allowed by the circuit, and then the address will be where? Then the address will be here, 20H here, and will be go to the memory, will be indicating the particular memory. So that in that way, so when ALE1, that means the circuit is active, it will allow the lower byte of the address, and that means that all the address line, lower order address line is acting as a address, lower order address bus is acting as a address line if ALE is 0. If AL is 0, that means we have provided a low value to the ALE. If AL is 0, we have provided a low value. Low value means the circuit, it will be the all the D flip-flop will be deactive, the whole circuit will be deactive. At that moment, if we wants to send some byte or the data through this circuit, through this time multiplex circuit, so data will not be allowed by that circuit. Then the data will, suppose the data is, I am just taking the data as data is 4, so 83 here. So 83 is here and 83 is a data. So then this data will not be allowed by the circuit because the circuit is deactive, because the ALE signal was 0, ALE signal was provided 0. So the circuit will be deactive, the data will not be allowed by that circuit. So the data will start to find the alternative way, that you can see the black line here. So the data will start to flow from this line, and will go to the memory. So that means microprocessor wants to send some data from microprocessor to the memory, then the data will flow through this data line. That means ALE is 0, the circuit was deactivated, and this lower order line act as a data line, that you can see over here. If microprocessor wants to, if the memory of the microprocessor wants to send some data to the memory, so at that if the memory of the microprocessor wants to send some data to the microprocessor, at that case the data will be come through this path and will be stored to the microprocessor. So as you can see, this process is a unidirectional, that you can see the symbol of that process, and this process is a bidirectional. Data can be transferred in both direction, from the memory to the microprocessor, or vice versa. So in that way you can describe the signal, you can describe the conversion between data bus to the lower order address bus. So this picture is so important, so for our topic. So that's all.